You made it back. Brilliant. Let's have a look at some chemical reactions. Welcome back to Science with Mr. Spowage. So before we go any further, let's understand what a chemical reaction is.
A chemical reaction is where at least two different substances combine to create a new substance. This means the bonds holding each of the original substances together have been broken and new bonds have been made. And how would we know if a chemical reaction has taken place? Well, we can tell if a chemical reaction has taken place because gas is produced, so we'd see either bubbles or fizzing, or heat is produced, and a new substance is formed. A chemical reaction is always irreversible. We often think in science about test tubes blowing up, and that is one form of chemical reaction. However, a lot of the time, actually, this would be a more accurate picture, where we just see bubbles forming, because a chemical reaction is taking place.
Don't forget, if you want to have a go at any of the experiments that you see today, make sure you've got an adult to supervise you. The first experiment we're going to look at is the Volcano experiment. It's the reaction between vinegar and bicarbonate of soda. Before we started, we had a quick test to see if bicarbonate of soda reacted with water. So Rory used 1 teaspoon of bicarbonate of soda and poured in 50 millilitres of water. Guess what? There was no reaction. It was very underwhelming. Next, we went on to test whether bicarbonate of soda reacted with vinegar. So Rory measured out again 1 teaspoon of bicarbonate of soda and we mixed it with 50 millilitres of vinegar. This time, there was a chemical reaction. There was some bubbles formed, but they went away quite quickly. So we wanted to see if we could make those bubbles last longer. So we used the same amount of bicarbonate of soda, but this time we added some soap. Then when we added the vinegar, we noticed the bubbles lasted for a lot longer. That's because the soap has changed the surface tension of the water. We also made a bit of a mess of the kitchen. The reason this is happening is because the bicarbonate of soda is reacting to an acid. So, can you think of any other acids that we could test as well? That brings us on to test number 4, which was bicarbonate of soda with lemon juice. And because lemon juice is an acid, a chemical reaction happened again. But again, the bubbles didn't last as long as we hoped. So we tried the same as before. We tried some lemon juice, but this time with some soap in the bicarbonate of soda. As you can see, we got lots of bubbles, but not quite as many as in the second test we tried. They didn't quite make it over the edge of the glass, and we didn't make quite such a mess of the kitchen. Now we had found the ingredients we wanted to use for our volcano. To start with, we wanted some bicarbonate of soda. Next, we were going to add some vinegar and some soap, but this time we wanted to add some food colouring to the vinegar as well, just to make it look a little bit more interesting. As soon as the vinegar was added, the chemical reaction started. And although it wasn't quite as quick as we thought it might be, eventually the volcano erupted. Now, this isn't quite the same as lava, but it looks really cool, and it was surprising quite how long the chemical reaction lasted for as well. Let's have a look at the chemical formula. At the bottom of your screen, you can see the chemical symbols that make up this reaction. And there's 2 products that I'm interested in. The first one is H2O. You might better know that as water. And the other is CO2, which is a type of gas, carbon dioxide. These are both produced when this chemical reaction takes place. To show you this, here's a quick experiment to produce CO2. Inside the bottle, we've got some vinegar and we've got some bicarbonate of soda. As soon as we add the bicarbonate of soda to the vinegar, the balloon inflates. This happens because CO2 is being produced by the chemical reaction and it's being trapped inside the bottle and balloon. That balloon is now full of carbon dioxide. Let's move on to a different chemical reaction. These ones are called pop and lava lamp. This one's going to use an effervescent tablet, which is a mix of aspirin, citric acid and sodium bicarbonate, and water. This one probably had the simplest setup of any. Take an effervescent tablet and drop it in the tube, add some water and put the lid on. Then there's a bit of a waiting game. As the CO2 is produced inside the tube, eventually the pressure becomes too great and it forces the lid off. Let's let Rory explain.
The water mixed with the tablet.
Yeah, the effervescent tablet.
And when the water got on it, the lid popped off.
Yeah.
There was loads of gas bubbles.
That's it, yeah. So the effervescent tablet had a chemical reaction with the water that made gas, and then, because the gas is all squished into this area, it's then popped off.
Yeah.
That's a good one, isn't it? There it goes again.
It's actually the sodium bicarbonate breaking down and reacting with the acid that produces the carbon dioxide. Let's try another experiment. Here, we're going to make a homemade lava lamp by adding water and oil together. And obviously, because of density, one floats on top of the other. We're then going to add some food colouring to the water to make it look more interesting again. And then when we add the effervescent tablet, the chemical reaction starts. Gas bubbles are produced which force water up to the surface of the oil. As soon as the gas is then released, the water falls back to the bottom of the glass, creating a cycle. This is a great experiment to try at home because as soon as the chemical reaction has stopped, you can leave the glass to settle and then do it all over again. For the next experiment, we're going to make plastic using milk and vinegar. Sounds impossible. Let's have a look. To start with, you need some warm whole milk and you need some vinegar. As soon as you add the two together, the chemical reaction starts and it's pretty instantaneous. The proteins in the whole milk bond to the vinegar and it creates this new substance called casein. Caseins used to be a form of early plastics, but they're still used today. You can then separate the casein from the liquid by straining it. This starts to remove some of the liquid from the casein and starts the drying out process. The milk also looks a bit clearer because it's had the protein removed. Now you can take the casein and you can start to shape it. In the 1920s and 1930s, people made a lot of buttons out of these because they could withstand the heat from an iron. Also, people made combs from them. I don't know if I could use a comb if I knew it had been made from milk and vinegar, but each to their own. So all of these have been examples of chemical reactions, and all of them are irreversible reactions. We can't get back to the original ingredients. Time for a quick quiz. Which of these is a chemical reaction? Let's see if we can find some more examples of chemical reactions in everyday life. Digestion, popping candy, photosynthesis, fireworks, rust and cement. Which of these do you think are chemical reactions? 3 seconds to think. Here comes the answers. Digestion is a form of chemical reaction. Your stomach uses stomach acid to break up your food. Popping candy is a form of chemical reaction. The chemicals in the popping candy respond to the saliva in your mouth, creating that popping sensation. Photosynthesis is a form of chemical reaction. It's a chemical reaction that's caused by sunlight and it creates sugars for the plant to feed on. Fireworks are a great example of a chemical reaction because not only does the chemical reaction give off colour, it's also what causes the explosion. It's an example of an exothermic reaction which creates heat. The sudden release of gas is what we hear as the bang. Rust is also an example of a chemical reaction. It can be found on iron or steel, and it's a reaction between the iron and oxygen and water. Cement is also a chemical reaction. Once water is added to cement, a chemical reaction takes place. It's exothermic, so it produces heat, and once the two have mixed together, It can't be undone. It's an irreversible change, just like all of these chemical reactions. In every single one, a new substance has been formed, so we can't get back to the original ingredients or substances. How did you do? Did you manage to spot all of the different chemical reactions? Hopefully you can now see that they're going on around us in the world all the time.
So, which was your favourite experiment? Don't forget, you could always email us with your photos and videos of you having a go. Don't worry, even if you're not in year 5, you can still send them in anyway. I'll see you next time. Bye for now.